So we're going to be talking about one of the ways to solve systems of equations, which is going to be done by graphing. So we're going to look at the first example. And it says solve the linear system by graphing, and you're given two equations that are both in standard form. So to graph, we have to make sure that both of our equations are in y equals mx plus b, and then graph from there. So I'm going to take my first equation, and it's going to be negative x plus 2y equals 3. And I want to get it into y equals mx plus b. So I'm going to add x on both sides because I want to get y by itself. So I have 2y equals, now I have x plus 3. I'm then going to divide both sides by 2. And I want to make sure I get all of the terms. So I have y equals 1/2 x plus 3.5. So I need to plot my y-intercept and my slope. So I always plot my y-intercept first. And if it's 3.5, that means it's really actually 1.5. So I'm going to start up 1.5. And then my slope is 1/2. So I'm going to go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. I'm also going to go down 1 to the left 2, down 1 to the left 2, and down 1 to the left 2. So I have my line, and I'm going to graph it. So that's my first equation. Now what I'm going to do is I'm going to take my second equation and solve that one for y. So I have 2x plus y equals 4. I'm going to subtract 2x on both sides. So I get y equals negative 2x plus 4. I always want to plot my y-intercept first, so that's my 4. So I'm going to go up 4. So 1, 2, 3, 4, and plot my point. I'm going to start there. Now my slope is a negative 2, so I'm going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and continue. And if you notice, the point where the lines intersect, that point that they intersect is at 1, 2. So my solution point is going to be 1, 2. So you need this for your answer. So I drew both lines. I found out where they intersected, and it was at 1, 2. So my next one is we want to do the same thing. We want to get them into y equals mx plus b first. So I'm going to take my first equation. I'm going to rewrite it. So I have x minus y equals 5. I want to get y by itself, so I'm going to subtract x on both sides. So I have a negative y equals negative x plus 5. How I get that y by itself is I'm going to divide each term by negative 1. And I have y equals, a negative divided by a negative is going to give me a positive x. A positive 5 divided by a negative 1 is a negative 5. So I'm going to start at negative 5 because that's my y-intercept. So 1, 2, 3, 4, 5. And I'm going to go up 1 to the right 1, up 1 to the right 1. And I'm going to continue my line. And then I'm going to plot it. So now I'm going to find my other equation, and I'm going to get that one for y. So I have 3x plus y equals 3. I'm going to subtract 3x on both sides because I want to get y by itself. So I have y equals negative 3x plus 3. I now need to graph to see where the two lines intersect. And I'm at negative 3. So I want to go up negative 3x plus 3. So I want to go up 3. 1, 2, 3. Now to get my slope, I'm going to go down 3 to the right 1, down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1. And if you notice, it's going to intersect at the solution point. Now that's going to be at 2, negative 3. So my solution point is 2, negative 3. Now, how to check if that's right, what I'm going to do is this is how you would determine if one is a solution. So you're going to take your original equations and you're going to put 2 in for x and negative 3 in for y. So if I took the first equation and put 2 in for x minus a negative 3 equals 5, let's see, 2, this turns into a plus 3 equals 5. That is correct, because what I did is I took 2 and put it in for x, negative 3 for y, and I got 5. I'm also going to see if this is a solution point, so I'm going to do 3 times 2 plus that negative 3, because that's my y, equals 3. Well, if I have 6 minus 3 equals 3, that's true. So 2, negative 3 is a solution point, and that's how you would determine if it is or if it is not.